Kia ora, and welcome to this Java version of the PhET molecule polarity simulation. Now I've got here the methane molecule. If I switch off the bond dipoles and molecular dipole, you can see it clearly, the one carbon that's surrounded by the 4 hydrogen atoms. And you will see that there's a bond dipole because there's a difference electronegativity between hydrogen and carbon. But because the hydrogen atoms are equally spaced around the carbon, there is no yellow arrow showing a molecular dipole, and you can see from this electrostatic potential that the electron density is spread evenly around the central carbon atom. So alkanes are nonpolar. If I look though at other molecules, so let's look at some haloalkanes, so the CH3F, you'll see there's a big difference in the electrostatic potential because fluorine is a lot more electronegative. And if I look at the CH2 F2, so the difluoromethane, then you can see there's also again a bond dipole going towards the electronegative fluorine side. And I can carry on with the CHF3, and you'll notice that the hydrogen is the more positive end and the fluorines are the more negative end. And finally, I can go to CF4, and we get eventually this nonpolar molecule again, because those 4 fluorine atoms are distributed equally around there, so all the bond dipoles cancel out. So what I'm trying to show here is that the haloalkanes tend to be polar, unless, of course, all the atoms are the same and equally distributed. However, if I compare this with, say, water, have a look at how intense the positive side is compared to the negative side. Or take ammonia, which again is very intense red and blue, although not as much as water. And that's why, even though, for instance, CHF is polar, it is not particularly soluble in water at all, because there's not such a big polarity difference. So it tends to form its own layer, and it's usually heavier than water, more dense, because of the chlorines or the fluorines being heavier, and therefore will settle out in the bottom layer. So just comparing again with the water molecule, you can see that this is a lot more polar, and so will not be attracted as strongly to the haloalkane, and therefore less energy is released to break these strong hydrogen bonds between the water molecules. So hopefully that'll explain why haloalkanes, although being polar, are not particularly soluble in water. Goodbye.